Alright. Hey guys, Mr. Milton here. Polygon angle sum theorem. It's on the table for today. At the end of this video, you should be able to use the two polygon angle sum theorems to find the missing angle measures. And you should be able to differentiate between convex and concave polygons. Differentiate, tell the difference between. Okay, a polygon is a closed figure with at least three sides that are segments. The sides only intersect at their vertices. Or endpoints, say that. Okay, so let's look at these and tell which one are polygons. First is a circle, not a polygon. There are no sides there. Okay, and if there were sides, the sides aren't segments. Here we have six figures, so hexagon. All the sides are segments. They all just meet at the vertices, and so this is a polygon. This looks like a four-sided figure, maybe a trapezoid, but we know that it has all segments and they only intersect at their vertices. And here, this is not a polygon, the reason being that they intersect here inside, so it doesn't intersect at the vertexes or vertices of these lines. So, no. So, no, yes, yes, no. Okay, so now that we know what a polygon is, let's talk about convex and concave polygons. We will typically deal with convex polygons. These are polygons with no diagonals, with points outside the polygon. Okay, if we draw our diagonals from one point, you'll see that at no point, does our diagonals bring our line outside of the polygon. Okay, that's how we can tell it's a convex polygon. Concave polygons are polygons with at least one diagonal with points outside the polygon. And so as we look here, we try to draw our diagonals from this point here on, working great. And now, look, notice that we had to go outside the polygon. So we know that this is not a convex polygon. Okay, so as long as there's one, it is a concave polygon. Okay, so we can do the same thing here. Sure, I'll do it here. Okay, so we draw our diagonals, draw our diagonals. So far, so good, so far, so good. And then, boom, outside the polygon. So it's a concave polygon. I usually think of it as the side being caved in, because cave is in the word. So if the side's caved in, we know that it is not a polygon. Okay, it's not a convex polygon. It would be a concave polygon. Okay, so we drew the diagonals. We see why the figure is concave. All right, so what I want you to do is I have another link for an enrichment sheet to talk about the polygon angle sum theorem. So go watch that and come back. Oh yeah, pause this video and then watch that and then come back. Alright, hopefully that was enough time for you to pause it and then go to the other link and come back. And now we'll move on from there and look at what you should have learned. So did you get it? If so, you should be able to answer each of these questions. Take a second, try to do that. Okay, so this first question says find the total degree measure of a 64gon. Well, in our enrichment, we should have found that, hey, we can find n minus 2 times 180 to find the total sum of any polygon. And so, since n is the number of sides, then we have 64 minus 2, which is 62. 62 times 180 goes 62 times 180. 11,160. 11,160 degrees. And there we have it. What is the total degree measure of any n-gon? That's, well, actually, that's this thing that I put up here. So any n-gon means number of size we unknown as of right now. We can find the total degree by doing 180 times n minus 2. Okay, that is a polygon angle sum theorem. Do the back of the enrichment worksheet. Come back to this page when you finish. Alright, that was enough time for you to pause it and come back to this video. Okay, did you get it? If so, you should be able to answer each of these questions. What is the total measure of all exterior angles of a 26gon? And that answer is 360. Okay. What is the total measure of all exterior angles of any n-gon? And that answer is 360. For exterior angles, we know that the sum of the exterior angles for any polygon is going to be 360. So there we have it. Not too much of an equation there. All right, regular polygons. A regular polygon is one that is both equilateral and equiangular. Equiangular. So a lot of people there we go. All right. A lot of people, when you say regular, they think that means normal. That does not mean normal. Okay. Regular means that all the sides and all the angles are the same. Okay. So we'll use that to find some missing values for our angles and sides even. But today we'll focus on angles. It says find the measure of each angle in a regular 15gon. So here's how we'll do this. First, we need to know what the total angle sum is for 15gon. And so we'll use our triangle angle sum theorem, 180 times 15 minus 2, or 180 times 13, which gives us 2,340. So that's the total of all of it, 2,340. But we're trying to find each angle, it means individual. And so since there's 2,340 total, and there are 15 angles for that to be spread around, and it is spread around evenly, then we'll do 2,340 divided by 15. 2,340 divided by 15, which is 156. So each angle in a regular 15gon is 156 degrees. All right. Second question says find the measure of each exterior angle in a regular 18gon. Okay, important now that we're talking about exterior angles. Okay, what do we know about exterior angles? We know that they always add up to 360. So we don't have to do anything to figure that out. It's just that it's 360. And then they told us that it was an 18gon, which means that it has 18 sides. So since it's a regular meaning all the angles are the same, 18gon, then all the exterior angles will be the same as well. So 360 divided by 18, that probably gives us 20, but I'll use my calculator, which will give us 20 degrees. Can I make that calculator smaller next time? Okay, so each exterior angle for a regular 18gon is 20 degrees. So in this video we talked about the polygon angle sum theorem, and we talked about the exterior angles, the exterior sum angle theorem. Okay, you should be able to use both of those to find missing angles in polygons. See you guys. Oh, and you should be able to tell the difference between a convex and concave polygon. There we go. Now, see you guys.